So now we're actually able to launch into some examples. Okay, so first though, again, let's look at the example f equals x squared plus 3. So you know the derivative is 2x, but the key is the 3 basically goes to 0 because there is no x variable there. So first, let's take the partial derivative about the x variable. So what we do is we look at the function, and the first thing we see is x squared, so the derivative is 2x. Next, we see y to the 5th. The derivative is 0 because there is no x. Just like the derivative in my example up above of the 3 is essentially a 0 because there is no x. So my derivative was just 2x. Now let's focus on the next question. df dy, which is to take the partial derivative about the y variable. The first term is x squared, and the derivative is 0 because we're focused on the y, and there is no y in the first term. Now we look at the next term of y to the 5th, and the derivative is 5y to the 4th, and so our final answer is just 5y to the 4th. Now we're going to look at the partial derivative of x evaluated at the point 3, 2. So first thing we do is find the partial derivative of x, which was actually the first piece we found up here in green to be 2x. And now I need to look at the point I'm evaluating where x is 3 and y is 2. And since it was 2x, I'll go ahead and plug that 3 in for x to get 6. Therefore, my partial derivative evaluated at 3, 2 is just 6. And now for the last part of this question. I'm taking the partial derivative of the y function evaluated at 3, 2. So I find the partial derivative of the y function to be 5y to the 4th, where I need to plug in the fact that y is 2, and so 2 to the 4th is 16, 5 times 16 is 80, and I have my final answer. Now on to part B. I'm asked again to find the partial derivative of x. Remember, there's 2 ways to ask that same question. So first thing I see is an x by itself, whose derivative is 1. Now I see 3y. Remember, we're taking the partial derivative of x, and there is no x in that term, so I just get 0. And lastly, that 19, again, doesn't have an x, so our partial derivative is just 1. Moving on to the partial derivative of y, the first term is an x, so since there is no y, we have a 0. Then we look at 3y, whose derivative is just 3, and 19 with a derivative of 0. So we just have 3 as our final value. Now, taking the partial derivative of x, evaluated at the point 3, 2, we start with the partial derivative of x, which was just 1, and there's nowhere to put x equals 3 and y equals 2, so we're just done. Our answer is 1. Same thing for the last part of this question. The partial derivative of y, evaluated at the point 3, 2, is the partial derivative of y is 3. Again, there's nowhere to put in the x and y values, so we just have 3. Now here's something important to catch at the bottom of this note. It says in part A, over here, when we did the partial derivative of 3, 2, about the x variable, I think I said that weird, but anyways, my blue one, we just got 6. We just got a number answer. And then in part B, in part A, when we just took the derivative, we had x's and y's in our answers, but over here in part 2, we didn't have x's and y's. So it could sometimes have x's and y's. It could sometimes just be a number. I don't know if that makes any sense. But if you're ever evaluating at a point, it will always be a number only, no x's and y's.